Okay, so here we are, problem, I believe it's number 14, and it's the contaminated, um, contaminated salmonella problem, and so I'm going to give you guys my big hint that I usually give, which is, so yes, you can draw trees for everything, but the reason we give you this formula, the reason that it's covered in the book, is because sometimes it's much quicker. If you realize this is the situation they're talking about, don't draw the tree. If they're giving you all the probabilities, sometimes it's really, really easy just to fill it into this formula. So make sure you understand what they're saying here is the probability of A given B is equal to the probability of A and B divided by the probability of B. So for those of you who want a hint, there you go. Try to apply that and put that in your toolbox for when you approach a problem. For those who want more, here comes more. So here we're going to define it. How I'm going to define it here is I'm going to call B I'm going to define as the event of being contaminated by, what am I looking for? Antibiotic that was, here, I gotta find it here. So they're saying find the probability that a ground meat sample that was contaminated by an antibiotic resistant strain. So contaminated by a antibiotic resistant strain. Okay, so there's the B. Now A will be the other part, where it is, so it's given that it's resistant to an antibiotic resistant strain, what's the probability that it was contaminated by a strain resistant to at least 3? So therefore this is going to be the at least 3 blah 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 blah. Okay, so now that's our definition. So if you need a little more of a hint, there's a little more. That's how we're looking to plug this, substitute this stuff in. Now, how I'm actually going to do it. I'm looking for the probability that it was contaminated by a 3, greater than or equal to 3, given that it's contaminated by a antibiotic strain. So now what I'm going to do is look through the problem for these probabilities. Do they give me the probability of something being contaminated by a strain that is not only resistant to 1 but also resistant to all 3? And we're going to find that. And the kind of nice part about this is if it is resistant to 3, therefore it's also resistant to 1. So really all we really need is the probability of it being resistant to 3, and that was 0.49. So the numerator is going to be 0.49. So then the denominator is going to fall into this group where we're saying, okay, we want the probability of B. B is just what's the probability of it being contaminated by an antibiotic resistant strain. And so that was contaminated by a strain that was at least 1 antibiotic was 0.84. So down here in the denominator we get 0.84. And we're done. Now we just do the division and that'll give us the answer to the problem. Hope that helped.